when you look at an amplifier system from the input or whatever kind of source that comes from to the output, whatever load it goes to, we could certainly look at it as being in multiple stages, and that would be very, very common. Most amplifier systems are multiple stage. And note that these are cascading, right? So stage one, its input is the source and its output is then for stage two. And stage two's input is the output of stage one, but it amplifies it and sends it on to stage three, and stage three's input is the output of stage two, and we finally then send it on to whatever kind of amplifier or whatever load we have. And remember gain. In this case, if it's a voltage amplifier, then we're talking about voltage gain. Is V out over V in, and it can be in volts per volt or it can be in dB. There's good reasons in situations to use either one. So this whole system might really look something like this. So we might have a input source with a source resistance, and it might go to a resistor. I'll put some names on these in a second, and then that might feed another amplifier. Or be part of another amplifier. And if we used a Thevenin construction, we could be looking at something like this. So let's see that. Another one. I'm not leaving enough room. Let me leave a little more room there. Still not leaving enough room. Wish this palm detection thing would work, and it wouldn't draw with my fingers, but it's what it does. Using the Zoom whiteboard, it's not quite as refined as it should be. So I might have 3 voltage amplifiers all stacked up in a row here. We have the original source, and we could call this. Well, let me just draw show you where the stages are. So actually, stage one is right here, and stage two goes from here to here, and stage three goes to here. This is the generator. So we go through an amplifier stage, and notice the amplifier. It has that input resistance and a voltage-controlled voltage amplifier and a output resistance. I'll label those all in a second here. And then we go from stage two, stage one, we go on to stage two, and we go on to stage three. There's lots of reasons to have multiple stages. It could be that that's the only way we can get some aspect of the performance. It could be that we can save more money by doing it that way. There's lots and lots of reasons. So the signal generator, the source, it has its own source resistance. I'll just do that sometimes. I can work with that. Except I need red. So we have a source resistance RS, and we might have a resistor here. We might call it 1 meg. It's actually the input resistor of stage 1. And we could have a voltage here, we call it VI1. It's illegible. We'd use a smaller size pen. A VI1. Then we have a V1 VI1 and R out 1. I'm going to just give it a value, call it 1K. And then we have the output resistance of this amplifier, and we might have 100K for here, might be what we need. And we have a voltage that appears across here, VI2. No, let's see, yeah, that'll be VI2. And then we have another stage, AV2, and it has an output of AV2 times VI2. And maybe we have a resistance up here of say 1K. And here we have 10K. And here we have VI3. The output of stage 2 is the input of stage 3, where we make AVI3, and we have AV3 times VI3. And maybe we have 10 ohms here, low resistance, because we might have a 100 ohm load. And we're seeing V out here. On that load or the output. That might be what an actual amplifier system, still abstract, but it might look like this, where we have these 3 stages. This is stage 1, stage 2, stage 3. I've drawn them, or kind of shown them a little bit different way, because I want to calculate what's going on here, and you might need to do this. So we really just have a bunch of dividers here. VI1 is this voltage value from this divider of Vs and this 1 meg resistor. So we could find that VI1 is just equal to 1 meg over 1 meg plus, I need to put in a value for the source resistance there. So let me change that RS. I'll give you a value there of, we'll call it 100K. So 1 e to the 6 plus 100K, e to the 3 times Vs. Excuse me, that's a divider. And if we do the math, then we'd have 0.909 times Vs is equal to VI1. Okay, I mean, it's a divider, and that's what we get. And then we can look at each stage. So for stage 1, I won't maybe go through such detail on each stage, but for stage 1, Vn is equal to Vi1. That's a terrible high, isn't it? And V out is actually equal to Vi2. I hope you can see that. The output of, so the stage 1 amplifier is right here, and its output is as far as this stage 1 is concerned, its load resistance is this resistor right here, which is where VI2 is created. It's kind of confusing, and you got to be able to draw it a way that it helps you understand what's going on. So we could understand what the gain of this stage is, what AV1 is. So AV1 would be equal to what we get off of this divider, this 1K and 100K divider there. So, well, let me write that out a little bit differently. If you're trying to find gain, I always recommend that you write the equation. First, let's find VI2. VI2 is equal to 100K over 100K plus 1K. And that's times VI1. And if I, let's see, how should I proceed? So, and we could give a value. We could say that AV1 is equal to 10, so that this amplifier here, this stage, this voltage controlled voltage source is multiplying whatever value of voltage we have here by 10 and supplying it to that Norton circuit or that Thevenin circuit. So with that, if we put all these numbers in, so that should be 10 times AV1. So then VI2 would be 100K over 100K plus 1K, or 100 over 101 times 10. And if we just do a little math, we'll get 9.901 times VI1. Or we could say that the gain of stage 1 is equal to its output, which is VI2, over its input, which is VI1, which is equal to 9.901 volts per volt. And if we do 20 log of 9 point that, 20 log of 9.901, that would be 19.9 dB. And we can figure out all the rest of these. I won't go on quite such long detail, maybe, I don't know. Stage 2. Again, its input now is VI2 and its output is VI3. And if we had AV2 is equal to 100, then the gain of stage 2 would be 10K. Got to be able to see that, don't you? We got 10K over 10K plus 1K times 100. And that would be equal to 90.91 volts per volt, or that would be equal 20 times log of 90.91 would be 39.2 dB. And then for stage 3, if we have a V on stage 3 of, we'll call it exactly 1, it's impossible to be exactly 1, but it could be very, very close. We'll call it that. And we've got these resistances of 10 ohms and 100 ohms. Then we can find out what happens at the very end there. So we've got a stage 3 would be equal to 100 over 100 plus 10 times 1, and that equals 0.909. And if we take 20 log of 0.909, and that equals a minus 0.829 dB. That's how that whole amplifier system works out. And if we wanted to find the gain from the output, the out, or from here, all the way back to the amplifier input. So that's a 3-stage amplifier gain. I'm not talking about back to the source here. I'm just talking about back to the amplifier input. If we want to find that, so we look at the total gain. That would be equal to the product of these gains. So 9.901 times 90.91 times 0.909. And if we multiply those out, we get, what do we get? We get 740, no, we get a little more than that. We get 818 volts per volt. And in dB, that would be equal to 58.3 dB. Now, if we wanted that total system gain, let's call it system, AV of the system, that total system gain, we need to go from the output all the way back to the source. So we'll go from the output all the way back to the signal source. And in doing that, we just got one more number to multiply. We would have this gain 818 times what we have at that input, which is 0.909. So we'd have 0.909 times 818, and we get 743 volts per volt. And that would be equal to 57.5 dB. Now we could have just added up those dBs and gotten exactly the same thing, because for amplification, for gain in dB, we add, and for gain in volts per volt, we multiply. But either way, hopefully you can understand. It's probably a little confusing what's really going on there. You've got to carefully keep track of where the inputs and the outputs are. The input of one is the output of the previous one, and it can get confusing. If you draw it out carefully and use good, careful naming conventions, it should be a lot easier. and work for you. I'll put some practice up here so you'll get some practice on calculating those gains, and also the volts per volt and dB thing.